y'all for your time.
Sorry.
No problem. Thank you all for your time this morning. My name is Steve Ripka. For those of you who haven't sat on one of these trainings that I've done for Jeff and the folks at BCNS on Wednesday morning, I manage the distribution channel for Belimo in the southern part of the United States. So I cover a big chunk of territory, and building controls and solutions is, of course, one of our biggest customers. So we appreciate the opportunity to come in, talk to you a little bit about our different products and technologies. Today, we're going to talk about something called Belimo PC Tool, which is a Belimo software application, which in and to itself may seem a little unusual. As I'm sure most of y'all know, Belimo really is not in the business of selling software. We're more in the business of selling end devices, valves, actuators, sensors, and whatnot. But the Belimo PC Tool's been around for a long time and will continue to stay around. We also will be working on some newer technology that's predicated on NFC to help communicate with Belimo products. But the Belimo PC Tool is basically a downloadable free software that anybody can get off of our website. So that is to say, the folks at Building Controls and Solution can all download it as long as your IT department permits, but your customers can download it as well. So anybody who wants it can have it for free. It's proprietary in the sense that it only works with Belimo products. But like most proprietary products, they require licensing and fees. Again, there's no licensing, there's no fees. Any updates or upgrades that are associated with PC Tool are also free. So again, it's something you can just browse to belimo.us, click on support. Under tools, you won't see it on the home page, but if you dig into tools, you'll find PC Tool version 3.16.1, which can be downloaded. You can also, of course, download a PDF file with the operations manual. However, it's important to know that in PC Tool, there is a help file. And of course, all the information that would be in the operations manual is also in the help file underneath the PC Tool software. So it's nice to have that O&M manual, but not 100% necessary because you can browse to it whenever you open PC Tool itself. So the main focus of PC Tool was based around the Belimo MFT actuators. So if you buy a Belimo airside damper actuator, you may see an AFB 24-MFT, or you may see a similar actuator like that on a control valve. So any MFT actuator that is either a damper actuator or installed on a control valve is applicable to using Belimo PC Tool. It also works with our electronic pressure independent valves, the EPIV. And we also recently introduced the Belimo airflow monitoring and control actuator. It's similar to a VAV style actuator, and PC Tool is also compatible with the MFT versions of that. You would need a release code, just a little plugin that goes into PC Tool to be able to set the maximum and minimum airflow values in CFM. That's something we can dig into a little deeper at a later time. And then another thing you may or may not be familiar with is Belimo offers up gateways. So we have these UK24 gateways that are applicable to Modbus RTU networks, BACnet over MSTP networks, or LAN networks. And basically, they take up one address on one of those networks, and then what they will do is they will communicate to up to 8 MFT actuators on their own little subnet. Those actuators have to be addressed and configured, so PC Tool can also be used to configure and address actuators that are being used in conjunction with our gateways. The things that PC Tool are not compatible with, and this may be a little confusing, in recent years, we introduced the P series of actuators. So primarily on our butterfly valves, you'll see the PRK UP-3-T, but more commonly for modulating applications, the PRB UP-T-MFT. Now, although that P series actuators has MFT in the part number, It's not really compatible with PC Tool. It's designed to work with near field communications. And on the PC actuators, you'll actually see a little NFC logo where either you can lay an Android phone on it and it'll communicate directly with the NFC chip, or we have a little gateway that if you're using an Apple phone, you can attach that to the P series actuator where the NFC logo is, and using the Belimo Assistant, you can configure those P series of actuators. To make it more confusing, just so you all know, if you connect to a P series actuator, you can actually view it with PC Tool. Where the problem comes up is that you're unable to write to it. So the P series actuators that you'll see on our, say, 8, 10, and 12-inch butterfly valves, or possibly in a standalone airside application, are really not compatible with PC Tool. And the Belimo energy valve also is not compatible with PC Tool. With the energy valve, you will either connect to it just using a web browser, backing it over IP or MSTP, Modbus, TCP, or RTU. So important to note that the energy valve and the newer P series actuators are not really designed to work with PC Tool. As I mentioned, the PC Tool is a software, and again, it's a free software. No licensing, no fees, nothing like that. You do need a small piece of hardware to interface your computer, your laptop, with the Belimo MFT product. So that product is called the ZTH-US, and it comes with a little orange handheld gateway that you see at the top of the screen. It comes with what is basically a printer cable or a USB AB cable, and then 3 specific cables that are used to connect from the RJ11 port on the ZTH-US to the actuators themselves. On the left, we have the ZK1-Gen cable that has a little programming connector that connects to a socket on the MFT style actuators that are non-spring return or electronic failsafe. However, again, there's always a little caveat. The larger EF spring return actuator does have an MFT socket on the bottom. So if you remove the NEMA 4 cover that covers up the wiring terminals, you'll find a little programming socket on the bottom of the EF spring return actuators. The majority of our spring return actuators, you have to wire into directly using the ZK2 Gen actuator or cable, which is in the middle. This is a 3-wire cable, and you connect it to the actuator's common, the white to the ground or the common cable, the blue of the ZK2 Gen to the positive or the VAC alternating current, what would normally be the red wire on the actuator. And then the green wire of the ZK2 Gen cable connects to the feedback wire. In most cases, that's going to be an orange wire. And what you're actually doing here is creating a little communications bus using the white or the ground or the common on the actuator and the feedback. And this is also how the actuators communicate when they are wired up downstream of one of the gateways. The common, the 24 volts common, and the feedback wire develop the communications network. And then I'm sure some of y'all are familiar with the SY actuators, the SY-MFTs. So you may have an SY120 or 24 MFT. They just use the ZK6 Gen cable that has 2 RJ11 ports. One connects to the ZTH-US and the other connects to the RJ11 on the communications board inside the SY actuator. On the PC side, again, the ZTH-US will come with a gray AB cable, which looks just like a printer cable. One side, the USB side, connects to your PC, and the other side connects to the ZTH. Of course, we want the actuator powered up, and essentially once we connect to a powered up actuator, the PC tool kind of takes over. So the actuator is going to stop responding to a signal from the controller unless it's in a simulation mode, which I'll talk about that simulation mode in a few screens. So once everything is downloaded and set up, you're going to get a dialog box that says you should adjust user-specific settings for future use. And that's actually a very simple thing. What you'll do is on the top, you'll see 3 tabs: File, Tools, and Help. Again, Help is where the O&M manual resides. Tools is where you're going to do most of your adjustments and add any release codes. And File is where you're going to generally go to start a new project or open up an existing project. So if you go to PC Tool Options or PC Tool and Options, you'll see the first tab is General. And essentially what you want to do here is simply adjust the language for English. As you all probably know, Belimo is a Swiss-based company, so a lot of our stuff defaults to German. So to make the PC tool a little bit more user-friendly, you'll want to go in and select English as your primary language. Simply click OK, and then it's best to, once you've clicked OK, browse, navigate on your laptop, your PC itself, to Device Manager, and then go into COM ports and expand that and look for ports, COM and LPT, and expand that. And underneath there, you'll see the port that the Belimo ZTH has been assigned to on your PC. This is probably the most common problem people have when trying to connect to an MFT actuator using PC Tool. And that is that the port is not set up to coincide in PC Tool with the way the port is assigned on the PC and Device Manager. So here we see under ports COM and LPT that we are assigned to port COM3. You'll want to go back to PC Tool and again open Tools and then go to MP channel configuration and make sure that your serial connection matches the COM port configuration in Device Manager. So as we see here, Belimo ZTH serial port COM3, we want to make sure that matches in PC Tool under MP channel configuration as well. You can see there's other things here. I have different modules. These modules are release codes that are designed to work with different specific products. So if you're maybe setting up a compact VAV or working on an EPIV, you may need to request a release code from your local sales manager. But for most of the generic air and water side applications, you don't need release codes. It's only for more specific products. So now you've got your COM port assigned. You're going to be able to communicate to an actuator. You've got your language set. The next thing you'll want to do to start up PC Tool and connect to a Belimo actuator is go to File. So on the top, we have File, Tools, and Help. On the far left, we have File. We'll select File, and you can do one of 2 things. The first time you're going to use PC Tool, you're going to have no choice but to select a new project and start a new project. There are a few parameters you have to put in to get the project started. You have to have a project name, the company, and a user ID. So the top 2 and then the very bottom blocks need to be filled out. Shop mark and comments aren't necessary. Generally, what I do is I use some element of the actuator or valves nomenclature and then a location. The company I use is Belimo. I would suggest, BCNS or whomever the contractor is, and then the user ID. I just generally use my name. So just basic information to keep your files organized more than anything else. However, once you've been using PC Tool for a while, you'll have a library of existing projects. So what you can do is if you're going back to a job with the same actuator, or you're working on a demo at the office or something, you can open an existing project and the PC Tool will discover that project and navigate to the actuator, whether it be an air side damper actuator, an actuator on a control valve, or maybe something more sophisticated like a VAV actuator, or possibly an EPIV, an electronic pressure independent valve with a flow meter and a smart actuator on it. Once the PC Tool and your PC uploads the parameters, you'll see the screen that says the Service tab. So your home screen is going to have 3 tabs: Service, Configuration, and Simulation. The home tab, the first tab, can be the other 2. So in this case, we're opening up to the Service tab. Configuration and Simulation can be selected as the landing page in the PC Tools option. And then you also have a tree that'll show you your channel, confirm that you're connected, all that stuff. And if you're using a gateway with multiple actuators downwind of the gateway, you'll see those actuators over here on the left side on the tree, kind of very similar to if you're dealing with a Jace that's got a bunch of controllers on a MSTP network. You'll see the homes, the main controller, and then the controllers on the network. The actuators underneath the gateway will look just like that. They'll look like VAV boxes or other controllers on other communication networks and other software applications. So that is to kind of say PC Tool, although it may look a little older, it does have a similar feel to some software apps you might be familiar with in the DDC world. One thing you'll see is, if we look at this example, this is obviously a brand new actuator out of the box. It's got no operating time, no active time, no stop-go ratio. It's going to tell you how the actuator is set up. One really important thing is we have those direction of rotation switches on the face of our actuators, and that can be set either here in PC Tool or mechanically or via the switch on the actuator in the field. The configuration tab and the service tab actually will let you know if the setting for the direction of rotation switch is the same in the field or on the face of the actuator as it is in the software. And it'll give you a little warning. It'll say does not match setting on the actuator. And of course, you kind of probably want those two things to coincide so your setup is consistent. An important thing to know is down here at the bottom, we have a messages tab. And if an actuator is in good health and in good working condition, here on the service tab, there'll be no messages. If you are in a situation where you've got a customer that says, hey, this actuator has failed, it is not working, for whatever reason, they're having difficulty with the functionality of a Belimo actuator, which I think we all know are pretty robust products, you may see a red message that says stop and go ratio with a specific percentage. This means that the actuator is being exercised or being commanded to move too frequently. Or for instance, the PI loop is a little too tight, so that the number of recommended modulations is being exceeded. Anytime you have airside actuators that are MFT actuators and they are problematic, the best thing to do is to go in with PC Tool, just go to that home service tab and look to see if there are any stop-go ratio messages. That'll answer a lot of questions very quickly for both you and your customer in the field. The service tab allows you to do a few things. You can test the actuator, you can adapt the actuator, and you can also synchronize the actuator. So you see over here on the right, we have test, adaptation, and sync. The top button, test, just simply runs a functional test to make sure that the actuator is opening and closing, it's going to the proper mechanical stop, or if the mechanical stop is at 90 degrees or 95 degrees, but the maximum and minimum angle of rotations have been set via the settings, it lets you know that the actuator knows that it's got a programmed maximum rotation of, let's say, 85 degrees as opposed to 95 degrees, and a minimum programmed degree of openings of, say, 10 or 12 degrees as opposed to 0. The synchronization is used if you do change the mechanical stops. So as you may be familiar, on most Belimo actuators, you'll have a little screw and set like mechanical piece that prevents the actuator from stroking any further. And if you want to mechanically change the end stop or the maximum degree of rotation, you can move that mechanical stop counterclockwise to decrease the stroke of the actuator. Whenever you do that, it's a good idea to run a synchronization. And what that synchronization does is it makes sure that the 0 to 10 or 2 to 10 volts spans evenly across 0 to the new mechanically stopped maximum degree of rotation. So that's to say the actuator is accustomed to doing 0 to 95 degrees. And when we use adaptation, we just simply stroke the actuator 0 to 95 degrees, and we span that 2 to 10 or 0 to 10 signal over that maximum degree of rotation. If you mechanically change it, the synchronization will make sure that 0 to 10 is resolute from 0 degrees to anything less than 95 degrees or 100% open. Always good to run a synchronization if you change the mechanical limit. Always good to run a functional test if you change any parameters like running time, torque, min, max, and min and max degree of rotation, things like that. So if you make software changes or parameter changes, a functional test is a good idea to run after those changes have been made. A test is going to basically look like this, and it's simply going to tell you if everything is plausible, if the actuator opens, closes, and if there's any errors. Generally, there'll be no errors. It's a pretty simple test. And up here at the right, you'll see the current position, and of course, that the test was successful. So that there was no errors, the actuator functioned properly, and we can go ahead and put that actuator or valve assembly into service, and it should work with no problem. The configuration tab is probably the most important tab within PC Tool, and it allows us to change different parameters of the actuator. One thing you'll notice is that on the very far right, we have a little picture of an actuator and a green check mark. That means that everything that's been uploaded from the actuator is the same as it would be in PC Tool. So our upload matches what our software sees, and there have been no changes made. Some of the things we can change on the configuration tab, one of the most common things is the input signal. Do we need 0 to 10 versus 2 to 10? Does it need to be a variable DC input like 6 to 9 volts or something like that? So you can see we can change that here on control signal Y. We can change that feedback. If for some reason the feedback needs to either match the output signal, like again, if it's an oddball signal like a 6 to 9 volt DC, we can change that there. The maximum angle of rotation and minimum maximum angle of rotation can be changed. Again, after changing those, it's always a good idea to run a functional test just to make sure everything's working. We can adjust the running time within its parameters. So there's going to be a minimum and a max runtime to most MFT actuators. You don't want to exceed or try to go below those parameters. Then one of the most important things, or not important things, but something that's good to know, is that you can reduce the sensitivity or the response of an MFT actuator. So in some cases, you may have an unstable control signal. Sometimes I find this with level switches or level sensors and boilers and that have feed valves on them, and that the level switch or sensor is erratic. So if you've got an erratic signal, you can go in there and reduce the sensitivity. So the actuator has like a delayed response time, and it sort of cleans up the resolution of the control. It's a good thing to know that's in MFT actuators, again, if you have some unstable control signals or just some controllability issues out in the field. We can also say what the actuator should do upon repowering or power. Generally, no action is common or synchronization is common when the actuator comes out of the box. So let's say we do change some things and the parameter does not meet the spec of the actuator. What you'll see is on the in the box where you made the change, there'll be a little red exclamation point, and it simply won't let you write that parameter down to the actuator. You've got to stay within the limits, and those limits are all visible here in the configuration tab. However, anytime you do make changes that are within the parameters and you want to write them down to the actuator, what you'll see is the yellow box indicates changes that have been made. And then on the far right, where we used to see a green check mark, now we see a red X. And that red X will be there until we click right. We'll see a little right splash screen come up. that lets us know we're writing or communicating down to the actuator. And then this will turn green again. So we'll know that, okay, I've written down to the actuator, pardon me, folks, all the parameters are good, and we are set to go. Then something you can do is that with PC Tool, of course, it builds its own little file structure within your PC, and it will allow you to store these parameters to a file. So maybe you've got a customer that ordered 25 or 30 MFT actuators because they didn't know what the control signal was, or they didn't know what the running time was specifically, but they knew the MFT actuator could be configured in the field, and it would take care of all the options. You can actually store these files in the PC Tool file structure, and then they can be recalled when you want to write the same parameters to multiple actuators of the same type. That is to say, if you've got a bunch of AFB24-MFTs and you want them all to respond to a 0 to 10 signal with a 2 to 10 feedback and run at 75 seconds maximum runtime, you can store those parameters from the first configured actuator and then load them from the file structure on your PC. So you don't have to go in and recreate those parameters for every actuator. If it needs to be done multiple times, it's just a load from file feature, a write, and you're good to go. Again, once everything's done, everything's been configured, everything meets the parameters that the actuator can adhere to and has been written down to the actuator, you will have that green check and everything is good to go. So you'll see this configuration tab will look the way it looked when you first tied into the actuator and uploaded it to your PC Tool. The third tab is the simulation tab. And this is nice to make sure you know that primarily that your actuator, whether it be on a valve or just on a damper, is actually following the control signal that you're sending it. That is the most common application for the simulation tab. And what we use here is the set point Y simulation. So we've tied into our actuator with our cable, whether it be the plug, the RJ11, or we've just wired in directly to the hot, the common, and the feedback. We can still have a signal going to the actuator from the controller. But as I said earlier, once you're tied in with PC Tool, the actuator is going to ignore that unless we go into a set point Y simulation. So we want to make sure, okay, I'm sending this actuator a signal. I want to make sure not only that it's getting the signal, but it's also responding to that control signal as expected. So here on the simulation tab, you can see at the very top, we have, not at the very top, we have simulation off, and then right below that, we have set point Y. The set point Y, again, is the most common simulation we utilize. We want to select that, but then until we select trend record, nothing's going to happen. So right now we've selected set point Y. We want to look at our control signal, but we haven't started the process. Down below, there's going to be a little button that says trend record, and it'll be red. But once we click the trend record button, it's going to turn green, and we're going to see some lines. We're going to see some things that indicate what's going on within this actuator. And this can be very helpful because you'll actually know if we're doing what we're supposed to do. So the top and bottom blue lines are going to indicate the minimum and maximum angle of rotation. The green line that we see here that comes from the bottom and starts to work its way upward is the control signal coming from the controller. And that can be, of course, coming from a normal DDC controller in the field, or if you need to use a signal generator for some reason, it can also work with signal generator. And then our dotted line, our dotted orange line, shows us the actual angle of rotation or position of the actuator, again, whether it be on a damper or a valve. So now we see that we've gotten an increase in the signal from the controller, and our angle of rotation is starting to match the request from the DDC controller or the signal generator. As that increases, that dotted orange line will follow that signal, whether it go up or down. Here, the example is just going up, of course. We also see here up at the top, we'll see values for the set point in percentage, and then the actual position in percentage. So we can make sure that these two values actually match as they're supposed to. So not only can you verify that down here on the screen, on the chart, but up here at the top, you do have set point and actual actuator position. So there's multiple ways to track this to make sure the actuator is doing what the controller is telling it to do. Once we hit those purple or blue lines, you will not see that dotted orange line go above or below those. So say in some cases, maybe we have dampened our maximum angle of rotation from 95 degrees down to 90 degrees, and we're giving it 9.99 volts or 10 volts, and the actuators, the control signal is expecting to go a little further than the actual maximum degree of or angle of rotation. The dotted orange line will not go beyond the max or min, or should not go beyond the max or minimum angle of rotation set up in that actuator. So this is a very, very basic example of a simulation on an airside actuator. When we use this on the electronic pressure independent valve, we can see many more variables, including flow and GPM, along with degree of rotation of the valve's actuator. So we really get a good snapshot of how that valve is performing in coordination with the input signal from the controller. These trends can be saved and emailed for reference if you need to. So when you stop trend record, so we have our little green button here, click the black little dot and it will stop the trend record. And it will automatically ask you, do you want to save this trend for future use? Generally, you will want to save it if this is an active job in the field and you want to confirm or have some backup that the product is functioning the way it's supposed to. It's a good idea to save these. It's also a very good idea to put some sort of file name in that makes sense to you, because the file name will start off with basically the product nomenclature itself, but then it gets a little crazy. So you may want to rename this using the part number of the actuator and maybe the job site, the equipment number, something that makes sense to you, so that when you call it up to share it or to refer to it, you know what you're looking for. I can tell you I've had files with dozens of these default names, and I had to go through almost every one to figure out exactly which one I was looking for. So again, when sending trend records or saving trend records, I really recommend that you put some sort of naming convention that makes sense to you and pertains to the project as well. You can recall these and view them from a drop-down menu. There's a little trend recall button up here on the top left when you're in PC Tool. And then when you bring up the trend recall splash screen, there'll be a drop-down menu here on the right. It will bring you a list of those trend records that you saved. And again, hopefully we've named them so they make sense and you can pull one up that makes sense and not have to look at all 20 or 30 of them to figure out which one you're looking for. And you'll see something that looks like this. And it will be a snapshot of your trend record with the graph and also an explanation of what the graph lines mean. And here on the left, there's going to be a little drop-down menu again that will allow you to email that. So you can either save this file to view it yourself. If you have a customer that wants to view this file, you can save it and then email it to them. So the trend records will live in the file structure of PC Tool, and you can pull them up however frequently you want to, view them yourself, or send them to a customer if the customer would like to view them or has any questions about what you saw in the field. I can say I've used this many a time with our modulating SY-MFT butterfly valve actuators. Something, a little bit of a digression. The MFT butterfly valve SYs have specific duty cycles. So sometimes they don't respond to the control signal. If the control signal is oscillating very quickly, the MFT control on the SY actuator may lag behind a little bit. So it's a good way to let your customer know or yourself know that maybe that PI loop's wound up a little too tight. You want to open up the parameters so it doesn't ask the actuator to change position as frequently. As I mentioned, you can hit File and email these trend records to whomever you want to send them to. One of the more common places PC Tool is used is with our electronic pressure independent valves, or the EPIVs. So y'all may be familiar with this product. It's been around since the mid-2000s, and it's a really flexible product. There was a time when you would look at the Belimo catalog and there would be pages and pages of EPIVs with different maximum flow settings. Nowadays, there's one EPIV for every body size except for the 2-inch valve. There's going to be 2 of those. One EPIV with a maximum flow of 76.1 GPM, another EPIV with a maximum flow of 100 GPM. So nowadays, there's just one part number for every valve assembly, and you can request a specific flow setting, a specific Vmax or flow setting to be configured from the factory. But if you or your customer doesn't do that, that maximum flow can be set in the field using PC Tool. So the PC Tool is still a very important tool when it comes to the electronic pressure independent valves. You can also change the control mode. So with EPIVs, we have 2 control modes, flow control and position control. I'm sure you're familiar with this terminology. Flow control is basically pressure independent control, and we follow the signal and match that signal based on a specific request for GPM, while position control is basically 0 to 90 degrees based on 2 to 10 or 0 to 10 VDC input from the controller. You may need to switch to position control sometimes for commissioning, and then switch back to flow control for balancing or for normal functionality. So the PC Tool allows you that flexibility. Again, just like on the other airside applications or even other valve applications, you can change the control signal input. 0.5 to 10 and 0.5 to 10 and 2 to 10 are 2 standards, but you can also do a volt DC variable for a 6 to 9 or whatever your variable control signal input needs to be if it's not a standard one. You can invert the signal so you can make it a direct or a reverse acting valve if need be. And you can also change the feedback signal or the feedback output signal to either flow in GPM or valve position. So that is to say the output, the 5-wire on the electronic pressure independent valve will let the input on the controller know either this is the amount of GPM flowing through this valve at this specific command, or this is the position the valve's actuator is at with no flow information. With the EPIVs, it's important to know there is only one feedback wire that can only send one type of feedback signal, whether it be valve position or flow in gallons per minute. If you need multiple parameters, so say you want to know valve actuator position, flow, and command, or you want to know position and GPM at the same time, we make a -mod version of the EPIV. So the actuator part number would be EP2-mod. The mod, of course, stands for Modbus. However, it's just a simple RS-485 card in there, and an EP mod version can also be configured for BACnet over MSTP. So if you need both GPM and valve position to do a critical zone reset, more than likely you'll want to go with the communicating version of the EPIV. But again, that's not really part of the PC Tool presentation. It's just a small digression so we know that the feedback from a standard electronic pressure independent valve is one single analog output that can be flow in gallons per minute or valve position itself. Some of the other things we can change, as I mentioned, the maximum GPM. So with the electronic pressure independent valves, they're going to be available with what we call a VNOM, a nominal flow. Basically, it's the maximum controllable flow for any electronic pressure independent valve. That maximum flow can be reduced to 30% of the nominal flow. So that's to say I've got an EV or an EPIV that's got a maximum or VNOM of 100 gallons per minute. I can change the maximum flow controllability down from 100 gallons per minute to 30 gallons per minute. Then what the EPIV will do is it will span from 0 to 100% signal, from 0 GPM to 30 GPM as opposed to 100 GPM. So just to clarify, EPIVs can be configured for multiple flows in the field. You're not married to that flow once it comes out of the factory. It can be done with PC Tool. It can also be done with the ZTH-US by itself, so you don't necessarily need a PC. But one of the biggest parameters that we change using the PC Tool or the ZTH-US in an electronic pressure independent valve is the maximum flow capability of that particular valve. You can also change the input signal characteristics. So in most cases and in default, the input signal characteristics are going to be equal percentage. That's because the majority of the time, electronic pressure independent valves, which are basically control valves with balancing capability or dynamic balancing capabilities, go on some form of heat transfer device. They go on a coil, maybe on an air handler or on a larger fan coil unit. And you want those equal percentage flow characteristics to mirror the power of the BTU output characteristics of a coil. So again, in default mode out of the factory, the Y or input signal characteristic is in fact going to be equal percentage. It can be changed to linear. Now again, if this is on an air handler coil, on a hot water to hot water heat exchanger, you want to maintain those equal flow percentage characteristics. But if in fact you may be using an EPIV in a bypass, that's where the linear flow characteristics would come into play. So as we know, when we size a valve for a bypass application, it's a little bit different than when we size it for a heat transfer application. In a bypass, we're simply moving water from the high side of the system to the low side of the system, or the supply side of the system to the return side of the system. Where sizing permits, so up to 6 inches and a bypass requirement of 713 gallons per minute, an electronic pressure independent valve makes a really, really good bypass valve, primarily because not only can we control the flow through the bypass, but we can read the flow that's going through the bypass. So instead of needing a control valve and a flow meter, the EPIV achieves both with one valve assembly. But again, as we're just moving water from high pressure to low pressure or from supply to return, we're not engaging in any heat transfer. So we don't care if the water stays on the supply side longer. In fact, we don't want it to stay there. We want it to move as the differential pressure transmitter tells the controller to move that valve open to move water from supply to return, or again, from high pressure to low pressure. So in that case, in a bypass application, using an electronic pressure independent valve, linear flow characteristics are actually very desirable. The linear flow characteristics at 20% command, you'll have 20% GPM, at 50% command, 50% GPM, and so on and so forth. So you'll have a very accurate bypass control, and you'll also have feedback letting you know how much GPM is flowing through the bypass at any given time. Writing and changing the parameters in an EPIV is pretty much exactly the same. The process is exactly the same as it would be to any other airside or standard actuator. You can just see that the options look a little different. We have control mode, whether it be flow control or position control, or control signal. Do you want to invert it to make it a reverse acting? And then you'll see the flow characteristics for both the controller or the input and the feedback. If you are using the feedback for GPM, it's important to note that we want to keep those flow characteristics linear. We don't want to change them to equal percentage. The input at the controller won't read accurately if you change the flow characteristics of the feedback to equal percentage. This would be the default that we see here. Other than the control signal feedback, here we have the control signal. I believe I changed it from 0 to 10, and flow control should be our default. So this is a EPIB I've kind of messed around with a little bit in the garage, but again, anytime you make changes in an EPIB, you'll see orange boxes and a red X. We make our changes, we write them, that X turns green, we get a green check mark, and we know that we've written our parameters down to the electronic pressure independent valve. Trend recall, simulation, all the other stuff is going to work exactly the same as it worked with an air side damper actuator. So the setup, the connection, whether you open a new project or create a new project, everything we discussed or everything I went over when it came to connecting to an air side actuator is going to work exactly the same when it comes to an electronic pressure independent valve. The one nice thing with the EPIB is you will never have to wire into it directly like you would with a spring return actuator. It's always going to have the little programming socket on the face of the actuator, whether it be fail-safe or non-fail-safe. So you always use the same cable with the socket for all the electronic pressure independent valves. And with that, that is my conclusion of our Belimo PC Tool training. Are there any questions?
It sounds like a pretty good piece of equipment.
You know, Max, it is. It's really intuitive and super easy. You know, I always, especially when I was a district sales manager, I always had the little ZTH hardware and cables with me. It's an easy solution to problems that might seem big in the field to contractors who aren't familiar with it.
No, I think you covered everything really well, Steve.
Thanks, Jeff. I appreciate that.
Yeah, that was a great presentation. Thank you.
Oh, no problem. Thank you, John. I know we finished up a little early, so I do apologize for that, guys. I tend to talk fast.
No, that's a lot of good information. The EPIB is definitely something that should be in the spec moving forward.
Yeah. And, you know, of course, we try to drive that as well on our side.
Awesome.